Welcome to our next lesson, guys. This one is on powers with whole number exponents. So to start out with, we're going to talk about exponents. And in mathematics, exponents are used as just a short way to write repeated multiplication. So we can apply this and try and determine the volume of this cube. So we can look at this cube. It has side lengths of 2 on each side. And the formula for volume would be length times width times height. We can also write that as 2 times 2 times 2, or we can write it as 2 to the power of 3. So we can apply this and use it with variables as well. If we were to look at this other cube here and say we don't know the side length of them, we can label the side length as A, and then we can determine the volume of this cube by saying volume is equal to A times A times A, which would be A cubed. Okay, so let's apply this to power. So remember that a power is a number that's written in exponential form. It consists of a base, which is the larger number on the bottom, and this is raised to an exponent, a number up here on the top. And so these two things are called the base and the exponent. And the entire thing is called a power. Okay, so let's apply this to some examples. So for these ones, we want to state the base and the exponent. The base for this first one is going to be 4. And then the exponent that it's raised to is 5. This next one here, the base for this one would be what's inside the brackets, which would be the -3. And the exponent is what we find up on, raised up to the right-hand side there. The exponent there is 6. Okay, so we can also apply this in situations where we don't have numbers as our base or an exponent. So for this example, the base would be x. This is what would be repeatedly multiplied. And the exponent would be y. All right, so let's talk about coefficients. Coefficients are a number placed in front of an algebraic expression. And in this one that I've written here, 6 would be the coefficient. It's the one in front of the variable of x. X would be our base, and 2 would be the exponent. All right, let's apply it to some examples. So for these ones, we want to state the coefficient. For A here, we have 8x squared. 8 is the number in front of the x, which is the variable, so 8 would be the coefficient. For part B here, we have -3z to the power of 9. Z is our variable, and -3 is the number in front of that variable, so that makes -3 the coefficient. For part C, this one is a little bit different. We have a to the power of 8 over top of 7. So remember that there's no number in front of this a, and what we need to assume is that there's a hidden 1 in there. So we have a 1 in front of this a. So really it's 1a to the power of 8 over 7. And the coefficient that we actually have in front of here is 1 over 7. So it's 1/7 a to the power 8 would be another way that you could write this. So your coefficient there is 1 over 7. All right, so you have to remember that exponents are used to represent repeated multiplication. But we need to make sure we're paying close attention to what portion of the power that the exponent is being applied to. So in this example, we have 7p to the power of 3. So the 3 is being applied only to the p. So we would write this as 7 times p times p times p, because we need to have that 3, the p needs to be multiplied 3 times. And if we have our other example of in brackets 7p, and that's raised to the power of 3, it would be 7p times 7p times 7p. Okay, let's look at some examples. So let's write each of the following for these ones as repeated multiplication. So in part A here, we have 3, and then we have a to the power of 4 times b. So 3 is the coefficient, and that coefficient gets multiplied times 4 a's because a is raised to the power of 4. So we would write that as a times a times a times a, and then we have to have it times the b as well. All right, let's look at another example. So for this one, we have 3 and then an AB in brackets raised to the power of 4. So at this one, 3 is your coefficient, and that is going to be being multiplied by AB, and AB is going to be multiplied by itself 4 times. So 3 times AB times AB times AB. For part C, we have 3a to the power of 4. That 4 is only being applied to the b. So when we write this one, it would be 3 times a, and then we would have b times b times b times b, because b is raised to the power of 4 and therefore being multiplied by itself 4 times. We look at part D, 3ab is inside the brackets, and that's raised up to the power of 4. So for this one, what we would actually be doing, the repeated multiplication, would be 3ab multiplied by itself 4 times. Now let's talk about evaluating powers. So with this first one, we have 10 to the power of 3. And what this means is that we have to multiply 10 times 10 times 10. When we do this, we get an answer of 1,000. If we have the second question here, 3 to the power of 4, again, your exponent tells you how many times you need to multiply this number by itself. So for this one, we have 3 times 3 times 3 times 3, which gives you an answer of 81. It becomes a bit different when you start to involve a negative sign, and whether you have brackets present or not. For this situation, where we have negative 6 inside of a bracket raised to the power of 2, this is a situation where we need to take what is inside the brackets, and this is what we have the repeated multiplication. So it would be negative 6 times negative 6. And in this next example, where we have negative 6 raised to the power of 2 with no brackets, this is again a different situation. Well, this is a situation where we assume that behind that negative sign is actually a 1. So there's a hidden 1 there being multiplied by the negative 6. And to solve this, we have to, in front of our 6 being multiplied by negative 6, we have to have negative 1 being multiplied in, which gives us an answer of negative 36. Go back and put the answer for this first one here. That one's answer is 36. All right, so last thing we're going to talk about is a zero exponent. So remember from last year, our general rule, is any base that's raised to an exponent of 0 always equals 1. So if we have a base of a and we're raising it to the exponent 0, that answer to that will always be a 1. So let's look at these examples. If we have 6 to the power of 0, the answer there would be 1. If we have a negative 9 inside of a bracket, because that 0 is being applied to that negative at 9, that answer would also be 1. This next situation in C, we have negative 9 raised to the power of 0, but there's no brackets. So we need to treat this like there's actually a negative 1 being multiplied by that 9. So we would have negative 1 being multiplied by 9 to the exponent 0. And remember that 9 to the exponent 0 would be 1. And so your answer here would be negative 1 times 1, and your answer would be negative 1. Not sure why it didn't show up, but that's what it is. For our second question here, we have a similar situation. We have 2 being multiplied 6 to the power of 2, and that's raised up to a 0. So we would have 2 times a 1, because 6 to the power of 2 raised to the power of 0 is a 1. So that would equal 2, because 2 times 1 is 2. So anyway, thanks for watching, and have a great night.